minutes. Thought I'd just share. So I got rid of a table for all this, so I'm just using one function at a time. I'll eventually add these to a table of some kind. And all I'm doing is transforming the value, and then I'm just going to need to switch on the value. So down here, when we do the for loop, we're going to see what kind of thing it is. So I'm going to switch on the type, and so yeah, and we're going to add some cases here. So if the case is a PEGN comment, then we're going to do this. Yeah, if it's we'll get rid of that too. And then we need to add all these things together into a single string and then add the entire string. So this buffer is going to come down here, and it's not going to be the value, it's going to be maybe the buff. I mean, that's actually, that should be fine. But the runes, for example, have to be combined into a single string. So the token is always going to be a string. If it's a rune, there's a good chance there's another rune. So we're just going to build them all up into a string and do a string match, which is the same as a single rune. So, but we don't want to add any of this stuff to the buffer right away. We're going to actually make another little buffer, a baby buffer. Oops. Barbie, actually, I mean, it doesn't matter. I don't know if that's faster or slower than the other one, but we'll see. And then we're going to do, whoops, B adds that plus the value of the type. Actually, I could just, well, yeah, I don't know what's slower here. This is always a question. I probably should benchmark the speed difference between yeah, we should probably benchmark the speed difference between these two. Civ equals nil. Yeah. B. Now we're gonna put that whole thing into a string. And yeah. Anyway, let me see if I can get my head around this. So we have a loop going on. So we're going to advance every sibling. We're going to start with the single PEGN node sibling. And we're going to go ahead and advance it. We already have the first thing. So yeah. So if there's nothing else, don't do anything. Just break out. If there is, and what type is it? If it's a comment, then we're going to add a comment. If it's, yep, there we go. And then at the end, we're going to add that plus a line return, which I don't think I can do like that. Fuck. Oops. I'm trying not to swear anymore, guys. And I think it's silly, but I'm going to really try not to swear because I want to be accessible to more people. And that means less swearing. The comment thing, though. Actually, the only thing that we're going to be at, you know what? So the default should be to break. Yep. You know why? Because if we have a comment, we want to do that at the end. The only thing we want here is a PEGN rune, a string, or a token ID. And we know that because why? Because that is in the spec. So that is in the spec for a token definition, specifically a token value, a rune, a string, or token ID. So token ID. And we can extract them as we go. So if it's a rune, then yeah, we just add it. So b equals sib.value. I'll probably want to make it into a string, I'm sure. I don't think we have any values though. I don't think we have any plain runes. We have mostly token IDs. So the token IDs are going to be tricky because we're going to have to look up what they are. I mean, if I just, I mean, this will just show you what it's going to work, what it's going to do, but, oopsie. Where's our B defined? Oh, wait. This action's being run for each thing, so we have to do closure for this too. Holy shit, really? That doesn't make any sense. Yep, we're going to have to use a closure for that. That's weird. Huh. That's kind of cool, actually. So, because, yeah, the buffer is a closure. So, yeah, and we have another little buffer closure. Yeah. Yep. Truth is that I guess I don't need it. I probably could do, so before we do any of this, the first thing could be just a quote, right? So we could do this. And then down here, we just do buff. Yeah. I mean, that should work fine. Yep, that should work. And then we don't need that. We just need that. That's all we need. Actually, we don't even need that. We can do, what the fuck? Wait, I mean, I swore I don't need to swear. Okay, that's how we're doing it. Fine. There. All right, so yeah, so I didn't add any values because, oh, we didn't see the type. Also, we're not advancing the next sibling, so. No, we need to do it as a string. Actually, all of them would be strings. This would already be a string because the values are always a string. So yeah. Oh, strings are working. Strings worketh. Max Latin and all them are not working. That's probably because token ID, we have to get more than that. So yeah, that's what I was gonna say. I don't even think this will work. This would be funny. I just want to see what's in it. I'm kind of cheating. What? What? I'm on all the time. I ain't even square. I'm gonna be back off here in about a half an hour. I just have an hour break between things, so I thought I'd get some work done and stream it. Something is afoot with token ID though. So yeah. Actually, you know what I'm gonna do? I'm just gonna blow this up. Pay more attention than yeah, I mean I'm streaming all the time now these days. I had it working and now I don't. So I've got I think it's first child. Yeah. We got the token IDs, and the token IDs are potentially going to, okay, so if we have a token ID, let's just say token ID. I just want to make sure it's matching. That's a problem. Yeah, it's not even matching. That's a problemo. That means the token ID is not being matched. And that is a problem. OT Verlin Sib. Come on, baby. Where are you? There you go. Token ID. So yeah. So I guess that is working. These other guys are runes. So the runes aren't working. Oh, that's interesting. Okay. Well, that makes sense. I feel much better. So actually, I'm guessing the token IDs were working. So that is sub.value. And then we're going to have to translate the values to do lookup token names. Yeah, this is, watch, if I go over here, this is going to be working. It's going to say character line feed. Nope. Well, I guess there's no value then. How about this? First child dot value. I bet you there is. Yes, I'm just guessing. But, you know. Yep, there it is. Characters from line feed. So I just have to translate those. That's not a big deal. I'm just going to have to look up in the token table what they stand for, which is interesting because I didn't think I was going to have a token lookup table, but obviously I do. Silly me. Which is funny because that's actually what I'm writing. I'm writing a token constants table, but I'm also going to have to write a token lookup table. And yeah, that is required. Otherwise, I mean, it's just a map lookup. I almost want to put it through a map lookup. I want to put it through, like, this is your ID and then have a one-to-one association. Those are always faster. But you know. So I want the token ID to be a constant. And wait a second here. Actually, I don't know if I even need the constants. I need the lookup tables for the tokens. So yeah, and there's two ways to do this. I mean, the cheap way to do it is to do a map, and then have it just look it up. But if I do it, since I'm doing code generation, I can do it as arrays, and they will be much faster. So yeah, it's the chicken and the egg thing again. I'm so tired of that. So what? Let's see. So we do. What would the value be? ironically, I need the table to do the lookup. But this is because other people may be using the reserved IDs. So it's actually going to be built into other stuff as well. All right, so that makes sense. But this doesn't make it any easier right now for me to do because I'm going to need to look up those characters from line feeds. Okay, one thing at a time. So next, what do we got? We have a string value, which is working. String values are working. What is not working is runes, and that's because it's a child situation. A child situation. Because runes are like plain or whatever. Yeah. I mean, I'm thinking about this. Let's go look at the AST. AST long. Yep, here we go. So we have okay, that's interesting. So, oh my god, that's not a rune type, is it? That's not good. All right, that's why it's happening, and there is no such thing as a rune type. Nope. You know why? Because they are not significant. Yep. See, it's down here. That's why. So we need a hexadec. We need Unicode, binary, hexadec, or octal. Unicode, binary, hexadec, or octal, which is important. That's why we have it that way, because I want to be able to do different rules. So yeah, this little lookup table here is going to come. We're going to cut and paste that out and put it someplace else later because it's going to be very useful. So hexadec value. There we go. There we go. That's a hexadec. And then we have Unicode. Unicode, which is actually, those are accurate names. The problem there is that, yeah, I think we're going to use because I think all the Unicode are capital. I think that's the standard. Yep. So that means I have to soft pad them with zeros. A sprintf. Sib.value at 0 v, and we want 8. Did I do that right? No, because it has a fucking plus in there. Yeah. And the plus is significant. It shouldn't be. Interesting. I'm going to have to do a little bit of parsing magic with this one. So yeah. Can you even parse a string? I don't think you can. I'm almost positive you can't. Oh, you can. Oh, fuck yeah. That's awesome. So yeah, now we need, so what is that? That's a number. We do it as a Unicode number. And we cast that. I wonder if I can even do that as a Unicode number. Nope. Nope. Negatory. I'd have to like parse it out and have it become an actual number, but I don't need to do that. Go to the hassle. Because I can just pad it. I can just soft pad the number. So yeah, there we go. 2, 3, 4, 1, 2, 3, 4. And then I can put a U dash. I think it's a plus even. Oopsie. Oopsie daisy. What do you mean I can't have a plus? It's not a fucking escape sequence. There. That's better. That's a standard Unicode character in Go. Hi, Liquid. Unicode in Golang. Unicode in Golang. Golang was invented by one of the creators of Unicode. Or two. Unicode string escapes. That's too much. Unicode string escape. \u o something 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 stack exchange. This. There you go. /u for the 4 one. If you do the capital, you can do more. You can do the big ones if you use a capital U. You know what I really need to do? I need to queue up. I need to do this. Lang, let's see, rwx.gg, lang, go. Then I can go look up the spec. I should have this on speed dial. Nobody even knows what that reference is anymore. All right, what am I finding? I'm looking for Unicode, the Unicode, the Unicode, the Unicode. Here it is. U plus. How do you escape it? It's \. I know it's \. And then, the Unicode letter is considered a letter. See, it says 0 through 9. Oh! Apparently it doesn't care how many you have. Well, that's nice. Shall we test it? You just have fun at speed dial. I don't think I need to pad it. So, yeah. How about that? How about them apples? I can just do that. I don't think I need the plus. Nope. I don't. I'm pretty sure that works. Not sure completely, so I'm going to test it right now. Identifier equals letter or digit. Sprint F. Okay, there we go. Here it is. /u followed by exactly 4 hexadecimals. /u followed by exactly 8. All right, there you go. Because Go values efficiency. It means it wants to know what to do. It doesn't have to be thinking about it. So there we go. That is your proper Go escape for Unicode character. Unfortunately, fuck, can I use that in a string? I think I can. Yeah, I can. Yes, I can. I know I can. Simple backslash escapes allow arbitrary values to be encoded as ASCII text. I think this is also for rune. If I were to put it in a rune, it would work as well. But yeah. There you go. Whoa. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Fuck. It has rune characters around it. I mean, it has rune quotes. I wonder if it's going to mess it up. Like if I have 2 Unicode characters, which I do for characters from line feed. Let's go look. Those are going to be looked up. These have got to be looked up, but if I had something else there. Not broken, so don't fix it. Agreed. Don't fix it. So yeah, it is what it is. And everything's covered except for our token IDs, which are a chicken and egg scenario because I have to have a table to look up what the ID values are, which is what I'm generating right now. So yeah, it's one of those things where I have to just generate it. Oh, but I can't just copy that one because these are built-ins. So if somebody wants to provide their own in their own grammar, they're going to have to provide their own lookup table. Is that right? Yes, that's right. So let's say somebody else defines a token. What would happen with that? If they'd have, oh my God. Oh my God, oh my God, oh my God. So I'm gonna, ooh, that's interesting. I'm gonna have to build my own lookup table first. Yep. Wow. I gotta get my head around that for a second. So if somebody, no, well that makes sense because according to the order of operations in a PEG file, that would be a grammar. That would be a violation of the grammar rules. Because so say for example somebody defines a token that is used elsewhere. Oh, I'm gonna have that problem, aren't I? Oh, I had this problem with ABNF where you had to reverse the order and make all the finite stuff at the beginning because they have to be defined first. You can look them up so you can look up the rest of the stuff in the file. Fuck. That just means that, wow, we have to write a constraint on that on the grammar documentation that says tokens will be resolved first and then classes will be resolved and then everything else will be resolved. We have to put that in the order of operations. And if you don't do that, is that a violation of PEG? Please tell me it's not. I think that might actually be a violation of PEG though. Fuck. Well, if it is, so be it. That's why we'll call it PEGN. Because look, if we do... No, it can't be. It can't be. It cannot be. This is why you have to have the whole thing. It's also why these like event-based parsers suck, because they need the full context to be able to resolve things that are earlier in the AST. So that means if we open, see, let's check it. So I mean, his own example is Bork if we do this. Brian's example is Bork. It's Bork if you don't allow for that. All right, so here's his example. So I can zoom in. Can I zoom in? Zoom. Come on, zoom. I want to zoom a zooma. No zooming. Fine. You suck. Case in point, we have down here, we have a plus, right? But up here, we have a question and a plus. But the stuff down here is defined. So you can't, so if you're parsing this, you cannot parse this stuff and create generators for this stuff without parsing the entire thing first. And then you have to figure out how to resolve everything first. So the first things that have to be resolved are tokens, right? You can't, and so if you have a circular dependency, you're fucked. So like if this depends on this up here, and this depends on this up here, you see what I'm saying? You can't actually do that. So I'm glad we're going through this. This means that we can sort of codify the order of operations here, macro operations. We can say all tokens are resolved first. Boom. And that means that the tokens will be, that's what we're doing, right? And it also means that string, yeah, it means all tokens are reserved first. That means we actually have to create our token lookup table. Yeah, we're going to have to, wow, okay. Because we're going to have to, I mean, say for example, how can I make this clean and clear? So say for example, we get to the bottom here and we see all these strings right here, right? So this carriage return line feed just happens to be right here. Well, where's carriage return line feed? They're not resolved yet. Well, they are. These are in order, but let's say they weren't. Let's say this was up here, right? So it has to be able to go get it. So what this means is that any compound, any token ID that has more than one, so it's like a compound. I wish I almost could make it a different type. Yeah, I mean, I've been trying to. I'm kind of annoyed that there's only so many conventions we can use according to the capitalization and stuff. We've run out of them. You can't identify syntax through through punctuation and capitalization further. I mean, I could, but I don't want to. It's ugly. My point is that this says that fundamentally I have to resolve what CR is before I can do this. I can't resolve this unless I know what CR and CLF is. So if I come to this, it's like, I don't have a CR or CLF. Okay, we'll try again later. Right? So we come back and do a second pass. So what that means is we're actually going to be doing several passes through the whole AST to resolve things. So the first thing we're going to build is I didn't want to do it this way. We're going to have to make it a map. I don't want to make it a map though. It's too fucking slow. Suck. I guess yeah. The only, well, this sucks a little bit because there's some conditional logic we have to do. What is RobOS coming? Not for a while, Malcolm. So you see what I'm saying? Because we've got to resolve. So there's some conditional logic. The logic goes like this. If I have a token ID, so let's just assume token IDs are first, right? Okay. If I have a token ID, if I'm a rune type, right? These are all runes. Runes are binary or whatever. This is a token ID type. So these contain rune types. So all of the string tokens, all of the token definitions that contain values that are only runes and or only strings can be resolved first. And if anything has another token ID in it, that's really all it is. So the only situation, this is interesting. So the only situation that we have to bypass all of this stuff is if we have a token definition, a token val that has another token ID. You see? Because if we have, so basically this little loop that I'm doing, we have to skip every token value generation that has a token ID in it. We have to, first of all, we just have to skip them all. And the only ones that we resolve are the runes and the strings. That's it. And then, and we store those in a symbol labeled table lookup. And then we go back and we say, okay, where's all the ones that have token IDs? In any form. They could have been combined with a string or something. But if they have a token ID, then we resolve those because now we have a symbol table. We can look them up. And that's a two-pass situation, a two-pass parsing situation, like generation. And I don't like it. But it has to be that way, unfortunately. How's it going? So, a long way from there. I can't even get my compiler to work. But so yeah. So what we've found is I actually have to do two passes here. I was trying to get rid of this just on one pass, but I actually have to do two passes. Yeah. Yep. Do. So this code's all good and can be reused, but it's irrelevant because I have to do two passes. And I'm probably going to just do this. So we'll have a gen tokens that contains the others. Well, I could just copy that. What am I doing? And the but this is actually going to have two parts. It's going to have to generate two different sets of constants, and those constants will have lookup tables so that they don't have to use maps, because I refuse to use a map if I don't have to. I know it's more to write out, but who gives a shit? It's a direct index lookup, which would be much faster. I'm just thinking here. I wonder if it is faster. It's got to be. An array lookup, it's got to be faster. Plus another thing, there'll be finite arrays. They're not going to be slices on top of arrays. They're going to be finite arrays with pointers. So yeah. In fact, if I were doing this with C and pointers, how would I do it? I would have a symbol table, and I would have more than one thing pointing to those things. And I would be rejoicing because I'm not using Rust. All right. So, okay. Yep, I can see there's going to be several steps here. First one is going to be gen tokens simple, and that's oh well, Rust is worth learning. I just not first. Gen tokens. I almost want to say gen rune tokens. I feel like I'm writing PHP now. Or C, because I'm putting the underscores I threw out the convention for mixed case, and it's kind of starting to bother me. All right, we need to gen rune tokens. They have to be first. And the problem with this too is that we are also populating I'm going to actually have to populate an array inside of the generation stuff, which sucks. I don't want to do that, but I have to. And now it's getting very because it's going to be in the global namespace for this generator, which means that it couldn't be. Yeah, that sucks. I'm gonna have to encapsulate that, because I'm gonna need the table itself to do the other ones. Actually, no. You know what I can do? I can do it in here. Yeah, I can do it. There's probably a better way to do this. I'm just having fun. So it's gonna return the string of all the tokens, and that's it. So you're going to say generate the rune tokens, and they're going to get two things out of this. We're going to get a buff, and then we want to get, I think we want a map out of this. Yes, we do. We want a map, so we're going to get some more buff. Runes and a map. Runes, a map, and an error, actually. Do you need errors? I guess we could get an error. No, we don't need an error. We're either going to get runes or not. Oh, wow. Okay, so generate rune tokens. Where's our AST? We don't even have one yet. Oh, right. We're doing the walk down here and we're passing in the AST. Yeah, because it's part of the node tree. So we're just visiting. All right. So that's all in PEGN. Nice. All right. So gen tokens, roots, several passes over the tree, unfortunately. At least two. So we need to get the rune tokens and we need a map so that we can look up the tokens for the other resolutions. And what's another one that we just need that's just plain? Rune tokens and strings. String tokes. Rune tokes. Mac's gonna yell at me. String tokens. Okay, so the string tokens are just as easy to get. I mean, I guess with the rune tokens I could do. You know what? Let's just make them both strings. That's fine. Then we don't have to distinguish them. So if we say, because we're going to just be combining the whole thing together anyway. So yeah, we'll just say strings, string tokes, and that goes for string tokens, and that goes for runes. So we'll change this to strings. Includes all right, so then we guess we're gonna go through the thing and we're gonna isolate all of them and then we're gonna add them. All right, so that's great, that's good. And then we can return a map. We have to return a map from that. This is just for convenience. So our map is a map of strings pointing to other strings. Map string, the best of all. And yeah, a couple minutes left before my next session. So yeah, this is not hard. Use our map to resolve compound tokens, which we weren't going to allow originally. We actually weren't going to allow compound tokens, and now we are. So, well, I was just going to have runes only, and then it was like, well, okay, we're going to have strings, and now we have carriage return, line return, which is, you know, sort of a compound token. But that's it, and that's fine. That keeps this kind of generator code rather simple. If we had made the syntax a little bit more involved in that, we would have been in trouble. You know, when it comes to generation and validation, all this stuff. All the code that we're writing for generation, by the way, is all going to come into play when we start writing validation code. So code that just actually, yeah, because the validation code has to do an AST. There's check code. There's going to be parser code that's going to give us back an AST after it's parsed, and there's generation code, which walks the tree and generates the code necessary to, you know, create a next generation parser for the thing that uses the grammar to represent itself. So this is all going pretty well. It's slow. It's fun. This is not the kind of thing that I write every day, obviously. I don't think it's the kind of thing that anyone writes every day. So that's why I'm streaming it, because it's kind of fun. Maybe somebody else who really gets into this kind of thing can find it interesting. But I'm going to go ahead and have to sign off. We'll see you guys later. I don't know if it'll be tonight or tomorrow. Probably tomorrow. Bye.